Let's try question 8.93 from the 10th edition of Denniston. It says titration of 15 milliliters of hydrochloric acid solution requires 22.50 milliliters of a 0.1200 molar sodium hydroxide solution. What is the molarity of the HCl solution? So this is a titration of a strong acid, HCl, with a strong base, sodium hydroxide. So let's start by writing down the neutralization reaction that occurs when hydrochloric acid reacts with sodium hydroxide. And I end up with sodium chloride plus water. There's our neutralization reaction. We can also see that it is a balanced equation and that the ratio of HCl to sodium hydroxide is 1:1. What that means is that when I reach the end point or the equivalence point of this titration, that the number of moles of HCl should be equal to the number of moles of sodium hydroxide. Now what it's asking me to calculate is the molarity of the HCl solution. And the way that I would do that is that the concentration of my hydrochloric acid is going to be equal to the number of moles of HCl divided by the volume of HCl. I've already been given the volume of my HCl. It's right here. Therefore, in order to calculate the concentration of my HCl, all that remains is to figure out the number of moles of HCl. And I will know that once I calculate the number of moles of sodium hydroxide. The number of moles of my sodium hydroxide is going to be equal to the volume of my sodium hydroxide multiplied by the concentration. Let's convert the volume of sodium hydroxide into liters. And the way we'll do that is by dividing by 1,000. So I'm just going to do that in my head, and I'll get 0.02250 liters of sodium hydroxide. Again, I'm going to multiply that by the concentration, which is 0.1200 molar, which is moles of NaOH per 1 liter of NaOH. And immediately I can see that my volume of sodium hydroxide cancels out like that. Now again, from my balanced equation, I know that for every 1 mole of HCl, I have 1 mole of sodium hydroxide. So let's put that conversion factor into our dimensional analysis. So 1 mole of sodium hydroxide produces, or consumes rather, 1 mole of HCl. The moles of sodium hydroxide cancel out, and I get that the number of moles of HCl is equal to 0.002700 moles. Now all that's left is to plug the volume of my HCl and the number of moles of my HCl into this formula in order to calculate its concentration. Let's do that. So the concentration of my HCl is going to be equal to 0.002700 moles divided by my volume. It's 15.00 milliliters. Again, I'm going to go ahead and divide that by 1,000 in my head. So you move the decimal place over 1, 2, 3. So that would be 0.01500 liters. And when you punch that into your calculator, you get the concentration of your hydrochloric acid is 0.1800 molar.